So, given Engelbart's profound vision and the clear practical success his own team had in bootstrapping their productivity using these principles, let's pivot to the educational side. What are the concrete next steps for creating educational materials, maybe experiential learning opportunities for students today? Our goal here, as you said, is to help them really understand these principles: augmentation, bootstrapping, collective intelligence, and identify useful concepts they could actually apply in modern project teams.
Right? That's the perfect framing. We need to bridge this amazing historical vision with practical, modern application for learners. We can definitely outline a series of potential lesson plans that could do just that, giving students a mix of hands-on experience, conceptual understanding, and collaborative practice.
Excellent. Let's hear them. What's the first idea?
Okay, for a first lesson plan, I'd suggest something observational but powerful. Deconstructing the mother of all demos through observational analysis. The main activity would be simple. Have students watch Engelbart's famous December 1968 presentation, The Mother of All Demos.
Ugh, the legendary demo.
Exactly. And their specific task would be to tabulate how many of those features are things that fit into the day's general pattern of work. This actually aligns directly with a wish expressed in one of the source materials we looked at. Someone wishing they had done this exercise.
That's a brilliant way to engage them. So the learning goal isn't just, wow, look at this cool old tech, but for students to get a direct, concrete understanding of Engelbart's incredible foresight. They'd identify innovations that became totally ubiquitous, like the mouse, Windows, hypertext linking, but also, perhaps more importantly, those features that are still surprisingly lacking or clunky in many modern systems.
Precisely. Things like truly flexible, arbitrary jumping inside documents, outline structures with seemingly arbitrary depth, dynamic view specifications that could be instantly applied. It highlights both how far we've come and where we might still have gaps compared to his vision.
Okay, so the materials for that are straightforward. Just access to the demo video itself. Short and long versions are readily available online. Great starting point. What's next?
For a second lesson plan, we could get students much more hands-on. Hands-on with Fuji and LS, historical software emulation, and data exploration. The core activity here would involve having students explore the Fuji and LS project's GitHub repository. That's at github.com/kfest2025.
Fuji NLS. So they'd actually be engaging with a modern effort to recreate or work with the original NLS system. That gives them incredible access, doesn't it?
It really does. It makes the history tangible. Within that repository, they could do several things. First, they could run an Apple II emulator like AppleWin or MAME, loaded with the Fuji NLS disk image, which is named kfest2025.htv. This will let them experience basic NLS navigation firsthand, play with views like trim, levels showing hiding blank lines or statement numbers, and experiment with applying simple view specs like X for outline view or B to show more levels.
So actually using a simulation of the system.
Exactly. Second, they could examine the OPML source files that are also in the repository. These come from things like the Hyperscope 2006 project and contain preserved structural information, node IDs, authors, timestamps, the whole provenance for original augment documents dating back to 1991.
Wow, so it's not just a simulation of the interface, but interaction with actual historical data structures from Engelbart's later system, Augment. That's very concrete.
It is. And third, they could look at and discuss how the FujiNLS project itself uses modern tools, specifically AI-generated Python scripts, like ones generated by Claude, to process these historical OPM documents, maybe converting them to CSV or other formats, making this complex historical data accessible for analysis today.
That's a fantastic practical connection to modern AI right there. AI helping us understand the history of computing. So the learning goal for this lesson would be a really deep experiential understanding of key NLS features, its unique document structure, the importance of provenance tracking, and the tangible role modern AI can play in historical data processing and accessibility. Students are literally interacting with research materials available related to the NLS system.
Exactly. The materials needed would be an Apple II emulator, the FujiNet software or specific disk images from the project, and obviously access to the GitHub repository.
Okay, that's a great hands-on component. What about applying the deeper concepts?
Right. Moving to a third lesson plan, I'd propose something called the Trailblazer Challenge, experiential research and knowledge curation. For this, you'd assign students a complex problem to research, or maybe a specific historical topic within computing or another field they're interested in. The key is that they'd approach this task using the NLS document structure principles we've discussed, and explicitly drawing parallels to Vannevar Bush's Memex and his concept of the trailblazer. They would literally dive into the research materials available related to the NLS system or other relevant digital archives.
So this is where they move beyond just observing or using the old system and start applying the thinking behind it to a modern task, organizing complex knowledge.
Precisely. The sub-activities would really drive this home. First, students would need to identify useful concepts they want to explore for use on modern project teams, connecting the history to their own potential future work. Second, they'd create their own knowledge trails or dynamic hyperdocuments. They could use modern outlining tools like Workflowy, Obsidian, Notion, or even just simple linked documents or personal wikis. The goal is to organize their research findings, linking disparate ideas based on context and relevance, adding their own annotations, questions, arguments, mirroring the analyst system's addressability and its collaborative potential, even if they're working alone initially.
Building their own personal memex, essentially.
In a modern context, yes.
Yeah.
And third, as a reflective step, they could consider how modern AI tools like knowledge graph visualizations, semantic search engines, or even large language models could act as their automated trailblazer, helping them identify latent connections in their research or summarize vast amounts of information more effectively.
That sounds incredibly powerful for developing really practical, high-level skills. The learning goal here seems clear. Develop skills in information organization, associative thinking, knowledge curation, critical analysis of complex information landscapes, all directly applicable to modern research, project management, and just general knowledge work.
Absolutely. The materials would include access to relevant digital archives or databases, a choice of modern outlining or note-taking software, maybe even simple web development tools if they want to build a custom structure.
Fantastic. One more, maybe something collaborative.
Yes, exactly. For our fourth and final suggestion, let's put it all together with simulating collective intelligence, collaborative project application. The main activity here would be to organize students into small project teams, task them with a genuine collaborative problem-solving exercise, maybe analyzing a complex case study or developing a project proposal using shared digital workspaces. Think Google Docs, Microsoft Teams, Figma, Miro, whatever fits the task.
Okay, this sounds like where all the different threads, augmentation, bootstrapping, collective work come together in a practical, simulated, real-world scenario. Applying those foundational Engelbart ideas directly to how they work together.
Precisely. The sub-activities within the project are key to making this explicit. First, applying bootstrapping. Encourage the teams to consciously identify specific clerk work or executive superstructure tasks within their own collaborative project that could be better managed or maybe even partially automated by the digital tools they are using. Get them to reflect. How could improving our own tools and workflows accelerate our team's output? Just like Engelbart's team bootstrapped their NLS development.
So they're literally dog-fooding the bootstrapping concept on their own process. I love it.
Right. Oh, exactly. Second, facilitating disorderly processes. Structure the project, or at least parts of it, to explicitly allow for and even embrace nonlinear brainstorming and messy idea generation. Encourage them to use tools that allow for flexible organization, track changes automatically, reducing the fear of losing ideas, and generally reduce the penalty for disorderly processes, so the team's collective intuition can roam more freely.
Less pressure for immediate neatness, more freedom to explore.
Right. Third, natural contention resolution. Encourage the teams to document disagreements, alternative viewpoints, or open questions directly within their shared workspace, linking them to specific points. The idea is to let the evolving knowledge structure itself help surface and potentially resolve these points, rather than relying solely on synchronous meetings for every single minor point of contention.
Using the shared artifact as a tool for resolving conflict, not just documenting outcomes, that's very NLS-like.
It is. And finally, if feasible, multidisciplinary bridging. Try to form teams with students from different backgrounds or disciplines. Explicitly task them with noticing and actively bridging terminology gaps or conceptual differences within their shared document space. Let them experience firsthand the NLS advantage of creating that precise crossing of specialized languages needed for true collaboration.
Okay, the learning goal for this final lesson plan seems really comprehensive. A deep experiential understanding of the executive superstructure burden, the practical value of enabling disorderly processes and creative work, and the amazing power of amplified collective intelligence when teams leverage shared digital environments effectively. The materials are just standard collaborative online platforms and maybe some project management tools.
Exactly.
These lesson plans together seem fantastic. They really encourage students not just to learn about Douglas Engelbart, but to actually experience the foundational principles of augmentation, bootstrapping, and collective intelligence in ways that give them practical, transferable insights for tackling today's complex projects and teamwork challenges. It's about helping them build those cognitive superpower suits for the next generation.
That's the goal. And it brings us back to the beginning, really. It reiterates that Engelbart's vision from the 1960s wasn't just some.
It really does.
Yeah.
Which leaves us with some pretty provocative closing questions, I think. As we continue to deepen our partnership with these increasingly sophisticated AI technologies, the ultimate automated external symbol manipulation systems, Engelbart could only dream of what truly new forms of human intellect might emerge. What new modes of creativity, maybe ones we can't even conceive of yet. What entirely new levels of collective problem solving might become possible through this coevolution.
Mhm.
And perhaps just as importantly, what responsibilities does this profound potential influence place upon us right now? Responsibilities in how we design, how we develop, and how we choose to integrate these incredibly powerful AI systems into the very fabric of our work, our education, and our daily lives.
That's the heart of it, isn't it? It's not just about making smarter machines anymore. It's about consciously, thoughtfully shaping the future of human cognition itself. It's a question for all of us, really, technologists, educators, policymakers, citizens, all of us, to ponder deeply as we continue this journey into augmentation.
Definitely a lot of food for thought there. Thank you so much for joining us on this incredibly insightful deep dive into the visionary mind and enduring legacy of Douglas Engelbart.
Oh, it's been absolutely fascinating to revisit his work through this modern lens. Until next time, keep digging.